All right, hello, Math Aid. We've got a new unit. So, lesson 3-1, we're going to be talking about functions today. All right, so first of all, a relation. A relation is just where you have inputs and outputs, usually like x's and y's, that are connected to each other. And sometimes they'll be in a form of an equation, or there'll be a graph, or just sets of different points. Now, there are a special type of relations called functions. Functions are a relation where every input, or the x value, has only one output, a y value. Now, functions are nice because they're very consistent, they're done the same way each time, and they're predictable. You should be able to know what you're going to get for your input. So you plug in the input, and out comes the output. All right, so remember, they're consistent and they're predictable. All right, so let's say that the student store decided to get a candy vending machine. It has 6 buttons on it. So we got button number 1, that's for snooker bars. You got button number 2, that's for some N&Ns. And then button 3 is for Scuttles. Button 4, Twazzlers. And button 5 and button 6, they're both the same thing because they're pretty popular. They got the Hershey bars. So we want to find out if this, in the next scenarios, if this machine would be considered a function, meaning is it going to be predictable and is it going to be consistent as it goes through? Okay, so your input is us pushing the buttons. The output is the candy that comes out. All right, so first situation. Ruby, she's hungry, presses button number 1, boom, out pops a snooker bar, and she runs away happy and rejoicing. Bo comes up and he presses button number 1, and he also gets a snooker bar. They're both pretty happy. They pressed button number 1, and snooker bars came out both times. So, is this a function? Yes, that's predictable. The input had an output, and it was the same output each time. So it was consistent, and it's predictable. So we would say, in this situation, that this machine is a function. We had an input of pressing button 1, and we had an output that was the same every time. That is predictable. We got a snooker bar each time. All right, situation number 2. Let's say Eric goes in and he presses button number 5. So he presses this button here. He gets a Hershey bar, which is nice. Then a Leo comes around, presses the same button, and out pops N&Ns. Okay, so they both press button number 5. Eric got a Hershey bar, and then we got Leo over here, and he got N&Ns. That's not consistent. It's not predictable. We had the same input. We both pressed the same button, but we got 2 different outputs. We got an output of a Hershey bar, and we got an output of N&Ns. Almost said it the other way. So this would not be a function because it's not consistent. It's not predictable. The input of button 5 did not give us the same output. We got 2 different outputs. We have no idea what's going to come out next. It might be something completely different next time. We don't know. So that makes it not a function. We can't predict it. This would not be a function. All right, next one. Third situation. Laura presses button number 4. There's her button. Looks like she wants some Twazzlers. And she gets Scuttles instead. Now Kenny comes along and he presses that same button and he gets Scuttles. Now they both probably want Twazzlers, but they didn't get it. They got Scuttles. Now just because they got the wrong thing doesn't mean that it's not consistent and predictable. They both had an input of 4. They just didn't get what they wanted, but they both got the same thing. So this one would be a function. They both had the input of 4 and got the same thing. It's predictable. I know that the next person who presses button number 4 is probably going to get some more Scuttles. So this one would be a function. All right, next one. Kinsley comes over and she presses button number 6 because she wants some Hershey's, but she gets a banana instead. Oh, that's not good. Luke comes along and presses button number 5, and he gets a Hershey bar. Then Caleb presses button number 5 and gets a banana. So is this a function? Well, we pressed button 6 and got a banana. We pressed button 5 and got a Hershey bar. Then we pressed button 5 again and got a banana. So this one we're going to say is not a function, not because button 6 gave us a banana, but because button 5 gave us two different things. It gave us a Hershey bar and then it gave us a banana. So since it's not giving us the same output for the same input of pressing that button, we're going to say this is not a function. All right, sometimes we can write an association table like this for us pressing, several buttons. So it looks like this person presses button number 1 and get a snooker bar. This person pressed button number 2, got some Scuttles. 3, got some N&Ns. This person pressed 4 and got Snookers. This person pressed 4 and got Twazzlers. This person pressed 5 and got Hershey's. This person pressed 6 and got Hershey's. All right, so all those button presses, we've got 7 button presses there. Is there anything in here that makes it inconsistent? So this is not a function. Now, it's not a function, but not for maybe the reason you think it is. Button 2, they were expecting N&Ns, right? But they got Scuttles. But that's fine, because they were only pressed button 2 once. What makes this not a function is button number 4. Button number 4 was pressed once and a snooker bar came out. Then it was pressed a second time and Twazzlers came out. So button number 4 is going to be the button that makes this not a function. We had an input of 4 with 2 separate outputs. We input, got Snookers, input, got Twazzlers. Who knows the next time that I press that button what I'm going to get? Now, it's okay for this button to give me Hershey's and this button to give me Hershey's. That is fine. We can do that. As long as the same button doesn't give you 2 different kinds of candy bars. That's what makes it not a function. The same input giving you different outputs. So button number 4, which we would consider our input, gave 2 different candies. Gave us 2 different outputs. It gave us a Snookers and a Twazzlers. So that makes it not a function. You can't have an input give you 2 separate outputs. All right. Now we're going to just look at these in different situations where we actually have numbers instead of these made-up candy bars that I did. All right, so determine if each set of points can be a function or not. So over here, I've got 2, 9, 6, 9, 3, 7, 1, 6, 4, 10. So what we want to check for is, do I have any inputs that have more than one output? Well, 2 only gives me 9. 6 only gives me 9. There's no other 6s. 3 only gives me 7. There's no other 3s that give me another number. 1 only gives me 6. 4 only gives me 10. So each of these inputs are never repeated, and they're all giving only one output for that specific input. So this one would be a function. None of my inputs give me 2 different, how did I do that? No. None of my inputs are giving me 2 different outputs. Let's look at number 2. 5, 8. Input 5, output 8. Input 1, output 11. Input 6, output 21. Input 5, output 9. Input 3, output 4. So this one, I'm going to say is not a function, and here's why. This point here, 5, 8, and this point here, 5, 9. They have the same input of 5, but two separate outputs. So the next time I plug in 5, I don't know if I'm going to get 8. I don't know if I'm going to get 9. I might even just get neither 8 or 9, some other number. So this is not a function. It's not predictable. So explain your answer. The input of 5 gave me two separate outputs. I forgot to explain the other one. So the reason, explain the answer. For this one, every input only had one output. Now it doesn't matter that 2 had an output of 9 and 6 has an output of 9. The outputs we can have the same output. That's fine, as long as the inputs don't have different outputs. So we would say every input only has one output. All right, here we go. Next one, number 3. Input 0, output -1. Input 5, output 3. Input 6, 5. 4, 4. 6, 2. All right, so do we have any problems with anything there? Yes, we do. Input of 6 gives me 5. Input of 6 gives output 2. That's a problem. Input of 6 is giving me two separate outputs. So this is not a function. So the input of 6 gave two different outputs. Okay, next one. -10, -4, 14, 8, 6, 6, -10, -4, 8, 0. Now you might be tempted on this one to say that it is not a function. It actually is a function. Why? You might have noticed that we've got -10, -4, and -10, -4. Now the -10s, the input is repeated, but look at the output. The output is the same. So -10 only has one output. The one output is -4. What we're not allowed to have would be like -10, -3. Then we would have two different outputs. So even though it shows up twice, this is still a function because the output is the same. -10 still only has one output of -4. So every input has only one output. The end. All right, we're going to have a fun unit. I will see you on the next one. Bye-bye.